All right, so the first thing we'll do in this problem is go through and solve for the value of a. And so to do that, we're going to again represent the first three terms of this as y sub h of x. And again, this term back here will be yp of x. So we'll first take the first derivative. Y prime of x is going to be yh prime of x plus 3a e to the 3x. Y double prime of x is going to be yh double prime of x plus 9a e to 3x. And then finally, third derivative of x will be yh triple prime plus 27a e to the 3x. I mean, now substitute all three of those derivatives into our differential equation. So we're going to have our yh triple prime of x plus 27a e to the 3x, and then minus 2 times the second derivative, which was yh double prime of x plus 9a e to the 3x. And then we have plus 5 times the first derivative, which was yh prime of x plus 3a e to the 3x. And that must equal out to negative 24 e to the 3x. All right, so the next thing for us to do is observe that the first three terms in each grouping, the yh triple prime and the minus 2h double prime and the plus 5yh prime, they're all going to equal 0 because of the fact that they solve the homogeneous equation. So we're left with a 27 a e to the 3x, and then minus 18 a e to the 3x, plus a 15 a e to the 3x equals negative 24 e to the 3x. If we combine like terms, we've got 27 take away 18, which is 9. And then 9 plus 15, surprise, surprise, is equal to 24 e to the 3x. So it looks like our value of a is equal to a negative 1, which is very nice because that will simplify a lot of our work later on. And you can kind of tell that the author of this problem was thinking ahead by choosing 24 as that coefficient on the right-hand side. All right, so the next thing for us to do is now focus our attention on the initial value problem. So we now know that our y of x is a c1 e to the x cosine 2x plus a c2 e to the x sine of 2x plus a c3 minus an e to the 3x. And now we have to go through and sadly take the first and second derivatives to now impose our three initial conditions up here. So we need to first get our y prime and then get our y double prime. So we can actually fit y prime of x up here. That's going to be equal to a c1 e to the x cosine of 2x plus c1 e to the x negative 2 sine of 2x, and then we're going to have a plus c2 e to the x sine of 2x, and then we're going to have a plus c2 e to the x 2 cosine of 2x, and then we have our last term back here. The derivative of a constant c3 is 0. And then the derivative of the final term is minus 3 e to the 3x. So the next thing that we'll do is combine these like terms before we take another further derivative. So on the cosines, we've got a c1 e to the x plus 2 c2 e to the x. And again, that's times the cosine of 2x. For the sines, we've got a negative 2c1 e to the x plus a c2 e to the x. And again, that's times the sine of 2x. And then we've got a minus 3 e to the 3x back there. So the next step will be to, take the second derivative, and then we'll substitute in 0 into all three of these and find our c1, c2, and c3.